In Module 2, Lesson 16, we're going to take a look at even and odd numbers. And so in our opening exercise, we would talk about what even and odd numbers are and give some examples of them. So I'll just suggest some of the things we may have talked about. An even number is a number that can be divided by 2 with no remainder. And examples of even numbers are any numbers that end in 0, 2, 4, 6, or 8. An odd number then would be the opposite of that, and it is a number that cannot be divided by 2. Or in other words, there would be a remainder. And examples of odd numbers are any numbers that end in 1, 3, 5, 7, or 9. What happens when we add 2 even numbers? Well, we always get an even number. And so we would explore that by adding some even numbers. 2 plus 4 is 6, so that is even. 2 plus 2 is 4, that is even. 10 plus 18 is 28, also an even number. Pause for a moment and explore and see if there are any 2 even numbers that you can add together that would not give you an even answer. So then we'll explore why the sum of 2 even numbers is even. And we're going to think of the problem 12 plus 14, and we're going to draw dots to represent each number. So if I do 12 dots, so we've drawn 12 dots and 14 dots. The next step is we're going to circle pairs of dots, pairs meaning 2, to determine if any of the dots are left over. So there's one pair, 2 at a time. And we find that there are no dots left over. Will it be true every time 2 even numbers are added together? When we explored whether every addition problem with 2 even numbers would be even, I believe we found that all of those answers were even. So every time we add 2 even numbers, there should not be any left over when we circle the pairs. Next, we explore why the sum of 2 odd numbers is even. And we're going to look at the problem 11 plus 15 the same way that we looked at our even numbers in question 1. So we're going to draw dots to represent 11 and 15. We have 11 dots and 15 dots. In the same way, we're going to circle pairs of dots to determine if there's anything left over. Our pairs are obviously representing dividing by 2. And if you recall the definition of an even number can be divided by 2 with nothing left over. I have a leftover when I circled the pairs for 11, so I'll leave that there. Circle the pairs for 15. And I have one left over from that as well. And if I put this dot with the leftover in 11, we have a pair. Let's circle them together so we see that they are a pair. And now there are none left over. So the next thing you'll need to do is explore whether this happens every time you add 2 odd numbers. Well, every odd number is going to have one left over when you circle the pairs. And if you add 2 odd numbers, there will be 2 leftovers. So when you add 2 odd numbers, the answer will always be even. And then in example 3, we're going to look at why the sum of an even number and an odd number is odd. So we'll draw the dots to represent 14 plus 11. Then we'll circle the pairs of dots. To see if we have any that don't have a partner or any that are left over. There are none left over with 14. We circle the pairs in 11. And we find that there is one left over from our 11, and there are none left over in 14. So the answer to 14 plus 11 has to be odd. It has one remainder that doesn't have a partner. Will this be true every time an even number and an odd number are added together? We would expect it to be, because the even number would have pairs with no dots left over, and the odd number would have pairs, but there would be a dot left over. If the first addend was odd and the second addend was even, would the sum still be odd? In other words, if the 11 was first and the 14 was second, would that change whether the answer was even or odd? I think we can see that nothing would change. We would just have all of these pairs for the 14 on the right, and all of the pairs plus the extra for the 11 would be on the left. The sum is still odd. So to sum up the rules for adding 2 numbers, an even plus an even equals an even answer. An odd plus an odd equals an even answer. And an odd plus an even equals an odd answer. Next is an exploratory challenge that groups or individuals will do on poster paper. You're going to find whether each of the following products is odd or even, and you should use the dots in the same way that we did for addition, but keeping in mind that products are repeated addition. So when you show the products, make sure that you are showing the repeated addition of those numbers and then circling pairs of dots to prove whether the answer is even or odd. In summary, when you are adding, the sum of 2 even numbers is even, the sum of 2 odd numbers is odd, the sum of an even number and an odd number is odd. When you're multiplying, the product of two even numbers is even, the product of two odd numbers is odd, and the product of an even number and an odd number is even.